Hello and welcome to Utilizing Kubernetes and Open OnDemand to Support Virtual Classroom Labs. My name is Alan Chalker, and along with me is Trey Dockendorf. We're from the Ohio Supercomputer Center, and we're really appreciative of the opportunity that Dell has given us to give this presentation to you. For those of you who aren't really familiar with Open OnDemand, just have a few quick slides here, and then we'll get into the technical details. We like to say that here at OSC, as a result of kind of Open OnDemand, we provide supercomputing for anyone, anywhere. So that includes obviously Ohio-based academic institutions and faculty and students and scientists there. But also we provide services to others, commercial, business, industry, nonprofit organizations outside of Ohio. You see all those different dots there are clients of the Ohio Supercomputer Center, and they cover all kinds of categories all over the place. So in particular, we do provide a lot of classroom support. With the COVID pandemic, our virtual computer lab support replaced the ability that a lot of teachers and students had to go to computer labs on campus. Really escalated. It year over year was up over 200%, such that last fiscal year, as you can see, we supported hundreds of courses across just dozens of departments. In general, what we provide to those computer labs are a customized on-demand dashboard. They go to class.osc.edu and they see a very limited kind of stripped down version of our regular on-demand. Specific software packages, streamlined account creation process, reservations, things like that. Now, a subset of those classrooms, we are providing them services via Kubernetes. That's where I'm going to turn it over to Trey, and he'll talk a little bit about that.
All right, so our Kubernetes workload right now is mostly focused on the lightweight interactive workloads. This is traditionally 1 or 2. I think we have up to 4 cores per student. It is exclusively Jupyter and RStudio so far. We currently have 16 classes this semester that are using Kubernetes under the hood, in addition to the classes using Slurm. Our staff are the people that make the decision of whether or not to utilize Kubernetes based on their usage and resource requirements of each class, and also the number of students. As we do have a lot lower amount of Kubernetes resources than we do Slurm. Oops. All right, so the overview of technologies. First, cover Kubernetes is the open source container orchestration. Open OnDemand, which Alan covered a little bit, is a web interface to kind of make it a little bit easier for people to access HPC resources. One of the things it does is it makes interactive apps very easy to deploy. So things like Jupyter and RStudio. One unique thing with OnDemand compared to other web services is the web processes for each user that's logged in are running as that user. So you don't have a bunch of Apache or Nginx processes. They're running as each HPC user. OnDemand itself supports multiple resource managers. So like Slurm, Torque, and recently we've added Kubernetes. For Kubernetes, we deployed Kyverna, which is a policy engine for Kubernetes. The big benefit with this policy engine is you deploy the policies using Kubernetes resources. So you use the standard Kubernetes YAML files to deploy policies into Kubernetes. Some of the challenges we faced. One of the main ones was how to treat Kubernetes jobs similar to HPC jobs, and also allow the usage of a Slurm or Kubernetes interactive app from the same app code. One challenge with Kubernetes is typically or usually pods will run as root or can run as root, and that's very dangerous for file system access like GPFS. So one of the challenges too was ensuring that the pods were running as the UID and GIDs of the user running logged into OnDemand, similar to how OnDemand runs. This is needed for several things, including file system access. And one other challenge was how to charge users for their usage on Kubernetes, similar to how we do charging for the HPC batch environment. Some Kubernetes design patterns we used. One real big one was every user that logs into OnDemand gets a Kubernetes namespace with a user dash prefix and then their username. And this is bootstrapped by OnDemand when someone logs into OnDemand. We have role-based access controls for these namespaces to limit users to the operations exclusively needed to run on-demand jobs. Kubernetes itself authenticates with our Keycloak OpenID Connect, OpenIDC IDP, and we used OAuth 2 audiences to allow the on-demand tokens to also be valid for Kubernetes, which I'll cover a little bit in a few other slides. We deployed something we wrote in-house called the Job Pod Reaper. This is a tool for Kubernetes to clean up pods that have exceeded their wall time. The wall time is actually an annotation we add to the pods to tell this service how long those pods are allowed to run for before they get killed. Without this, pods would just run forever if a user doesn't actually delete it. We also deployed an in-house application called the K8 Namespace Reaper. So because every user logged into OnDemand generates a Kubernetes namespace, we didn't want unused namespaces to just sit around forever. So we wrote a tool that will clean up these unused namespaces over time. Some of the on-demand infrastructure to support this covered a little bit was we added a pre-pun hook. This hook is executed before the user processes spawn on the on-demand web node. This hook will bootstrap Kubernetes resources such as the namespace, the network policy, which prevents users from seeing each other's pods, and the role-based access controls. The hook itself is passed the logged in username and the OpenIDC token. And this token is used to set the credentials inside the kubeconfig so that we know we're able to authenticate with Kubernetes as that user. We do kubeconfigs on a per environment. So there's actually a context in the kubeconfig. So we have a different context for production versus test versus dev. The main on-demand instance and our classroom on-demand instance use the same context. So it's kind of like they use the same Slurm cluster, so they use the same Kubernetes cluster. OSC uses one instance of on-demand for general usage, which is available to all our users. And we have a separate instance that's just for classrooms. It's available to all our users, but it has a much more minimal environment, and we have much tighter control over how the apps are used. Some things we did in on-demand to support Kubernetes. So we have the kubeconfig I mentioned bootstrapped by the hook. The part of the kubeconfig not bootstrapped by the hook is the credentials. And so the credentials come from on-demand code. And that's used, or no, sorry, the hook generates the credentials, on-demand code generates the rest of the kubeconfig, like the API server, setting the context, the username, all that. All the kubectl commands that are executed by OnDemand are executed as the user logged into OnDemand. So the kubeconfig is stored in their home directory, and we're just using their home directory kubeconfig and executing commands as them because the web service is running as them. OnDemand forces the UID, GID supplemental groups to be that of the logged in OnDemand user. OnDemand adds a label to every pod for the count, which we use for accounting. Additional labels are allowed. Annotation that is added is the wall time. So this is essentially like when you tell Slurm how long you want a job to run for. We use an annotation set by OnDemand to set a lifetime for the pod. All the pods that are deployed are launched by OnDemand have a CPU memory request limit. And we also support requesting GPU resources from Kubernetes. The on-demand interactive apps that we use with Kubernetes is currently Jupyter and our Studio server. These are both used for classrooms currently only. We do have code to support in general usage. We just haven't enabled it yet. The apps that we deploy actually support both Slurm and Kubernetes. So when a user, if this was deployed to our general purpose cluster or general purpose on-demand, there'd be a drop down to choose Kubernetes or one of the HPC clusters. For our classrooms, that choice is taken away and we inject that cluster choice for them. So if we want them on Kubernetes, we set the cluster choice to Kubernetes. Along with that, yeah, a lot of the form options. So we don't allow users to select, well, most users in most classrooms can't select how many cores they use. They can't select which modules to load. All the form options that our general purpose on-demand instance would allow, those are taken out to simplify the experience for students, so they don't have to know what they really need. Some information about the pods deployed by OnDemand for Kubernetes. The pods themselves mount numerous locations. So we mount the user's home directory, we mount GPFS, we mount our LMOD apps and the initialization script to load LMOD. We mount the Slurm Mun socket so that you can actually run Slurm commands and submit jobs from a Kubernetes pod. And we mount the SSSD sockets so that the experience of like user ID lookups is a little bit better inside the pod. We use a cluster, quote unquote, cluster container image. It's an image we made that basically looks like an HPC compute node in terms of OS packages. And then, so this allows us to treat the pods like a compute node so that LMOD apps can launch and run just like they would in Slurm. And one limitation of this approach, and part of it is how we do home directories, is the only home directory location accessible to the pod is a user's own. So we don't allow sharing someone else's home directory or being accessible from someone else's pod. To make this more secure, we use the Kyverno policy engine. We deployed policies that ensure a UID and GID are set and they match LDAP, that the supplemental groups in Kubernetes set for the pod match LDAP. And we did a lot of additional settings that we enforce to ensure that the pods are running unprivileged and they can't access host file systems, or aside from what we allow, or that they can't escalate privileges. The LDAP mapping is actually an application we wrote called K LDAP config map. It dumps LDAP data into specially crafted config maps inside of Kubernetes that can be used by Kyverno. For accounting and general purpose Kyverno policies, we did a policy to enforce that the account labels exist so we can charge people for their usage. And we also make sure that account label value is valid and like the account hasn't been like deactivated or run out of credits. We also enforce that CPU and memory requests exist and those limits are set. We enforce that a lifetime has been requested, and we also set a max lifetime so a user can't just ask for days and days of pod lifetime. And we also ensure that the images used are pulled from a trusted source. A lot of these policies were written because we set the kubeconfig in a user's home directory, a very clever user could submit things to Kubernetes outside OnDemand, and we had to do things to prevent malicious activity. Here's an example of just the validate rule for one of our policies. This is the policy validate rule that ensures pods run as user. The UID is correct. I'll show some examples of what the data looks like. These are some validate rules. These are deny policies. So these will deny if the account is not in a valid list for that user. And it'll also deny if the supplemental groups list that they provided is not valid for them based on LDAP. And these are some of the examples of what the data structures look like in the config maps we generate. So here, you know, the key is the namespace so that the Kyverno lookups are very easy. And in some cases, it's the UID or the GID. Some cases, it's a string representation of an array of UIDs or GIDs. And then in others are a list of active groups. You'll notice my GID list is longer because we don't care if user supplemental groups are active, but the group list with the name, that's used for charging, and we only want active groups in that list. So it's a different LDAP query. And that's it. So I'm going to hand it back over to Alan.
Thanks, Trey. So just want to have a few end slides, particularly if you're not very familiar with Open OnDemand, what it is. You know, we talked about it a lot here. And it's a platform that we've been making available and developing for well over a decade. that basically allows people to efficiently utilize remote computing resources from any device. And it can be everything from your laptop to your cell phone. But the bottom line is you can use any web browser to access those resources. And if you run a computing center, what that means is that your clients can more efficiently utilize your resources and get up to speed faster on them. This is a list of logos of institutions that we know are currently using OnDemand in production. I'll point out that we have funding from the National Science Foundation to improve and develop and build this community. And they really want us to report back to them on who all is in the community, who's benefiting from this funded work that they've provided to us. And so if you do not see your logo on this list, we'd love to hear from you. We'd love to include your logo on this list because, again, we just, unless you tell us, we're not going to be able to put on here. And that helps ensure the growth of the community and the long-term sustainability. So if you want to find out more about any of this, about Open OnDemand, about what we're doing with Kubernetes, really encourage you to go to openondemand.org. That's our kind of one-stop shop for it. You'll notice we've got what's called a discourse instance. Discourse is basically an online web-based message board. You can also set it up in mailing list mode. And we encourage people to post on there or search on there because it builds a repository. And there's a lot of people in the community that are responding to questions and helping each other out because it is a pretty big community. We do have a mailing list that we send out updates on. You can also have Discourse mail you updates because we have an announcement section in there. And then we try to have roughly quarterly webinars. So I'll point out that we have I believe it's the first Thursday of every month. We're having a tips and tricks webinar that is community driven. We don't do any talking, it's just community members that give some tips and tricks. And then I think the second Tuesday of every month, we have open office hour webinars that if you have any questions and you just want to jump on a Zoom and ask us directly, we're just sitting on an open Zoom session there. So feel free to go to the Discourse instance to see details on those. I just want to conclude again by thanking Dell and Intel for sponsoring this session. And we're super excited that we were able to talk to everybody in the community about just using Open OnDemand with Kubernetes to support classrooms and support very kind of non-traditional HPC uses. Please feel free to reach out to us, ask us any questions, and hope you have a nice day, nice SC.